Right, we're going to look at infinite series, which is the last thing of chapter 19. Basically, for an infinite series, they're only useful for convergent series. So that's where r is less than 1, or the modulus of r is less than 1. Okay, so you've seen this series before, half plus 9 plus 27 plus an 8 ones, and I've said it's equal to a half. Okay, now you can use the summation formula to find this. Okay, so here we can use the SM formula. R equals a third, A equals a half. Okay, A is the first number, and we times it by a third each time. So I can use the formula. So Sn equals a third times 1 minus a third to the n divided by 1 minus a third. Okay? Now, in this case, Sn would equal, if I multiply the top bit out, 1/3 times 1 is a third, and 1/3 times a third to the n is a third to the n plus 1. Which is a third to the 1, I just add there, and then I can divide by 1/3 over minus a third, which is 2/3. Now, as n tends to infinity, it's bigger and bigger and bigger. This value here, 1/3 n plus 1, is going to tend to 0. It's going to get closer and closer to 0. So I'm just going to say that that is equal to a 0, because by the time I've got to infinite functions down the line, that's going to be equal to 0. So Sn is just going to be equal to a third divided by 2/3, which happens to equal a half. Okay? Now, I can use this in a more general way by using this formula. Okay, by the same principle, I can say that this is equal to, I can say, because r is less than 1, as n tends to infinity, Rn will tend to 0. Because if this is less than 1, if I keep repeatedly multiplying by a number less than 1, eventually it will get so close to 0, you might as well call it 0. So because of that, I can say that this term here is equal to 0. And so that gives me, for S infinity, which is obviously the number, it gives me A over 1 minus R. And this formula, again, is in your formula booklet, and it's what we're going to be doing 2 or 3 questions on now, using this formula. Okay, so the first question is question 1b. I want to find S infinity for this sequence here. Okay, so as always, you write down what we are. So A is equal to 12, R is equal to a half, and obviously n we know is infinite, but we know that. Okay, so I can say S infinity is equal to A, 12 over 1 minus a half, which is 24. Okay, that should be easy. You can do question 1 now. Question 2, I'm going to do question 2a. Now I know we're going from 1 to infinity. Now obviously I can't write out all those numbers of things, and I can't write in Sn because this because I have to figure out what is r first. Okay, so if I write out the series, okay, it's 0.8 plus 0.8 squared plus 0.8 cubed. Okay, so from carry on. So from this, quite clearly A, the first term is 0.8. R, which is the multiplier, is also 0.8 because I keep multiplying by 0.8. N, we know is infinity. Okay, so I can say that S infinity is equal to A, 0.8 over 1 minus 0.8, which is 0.8 over 0.2. Which is equal to 4. Okay, simple enough? Right, the last one. Okay, if the sum of our series is 4 and the second term is 1, okay, I want to find the first term. That's not exactly what it is, it's the second, third and fourth, but once you found, all you want to really here to do is find the common ratio. Okay, so I know that 4 is equal to A over 1 minus R. Okay, now A is the first term. is going to be 1, because that's the second term, divided by r, which is the common ratio. Because to get back to previous term, we divide instead of multiply. Okay, so I can write this as 1 over r divided by 1 minus r. Okay, therefore I can say that 4 times 1 minus r is equal to 1 over r. And I can, if I rearrange, sorry, that should be r. If I rearrange this, I can say that r, 1 minus r, equals a quarter. And if I multiply this out and collect all the like terms, I get r squared minus r plus a quarter equals 0. Okay, and this factorises to r minus a half squared equals 0. Therefore r is equal to a half. So if I know the common difference is a half, I know a is 1 over r. So a, which is 1 over r, is equal to 1 over a half, which is 2. Okay, so it's a matter here of this is basically working in the other direction compared to what it is. Infinite series tend to be a bit easier than the actual geometric series that limit to finite terms, but you can still use the formula. Again, finish off 19f, okay, and when I come back, we'll carry on with just the revision. Okay.